Hello everyone, welcome to Civil Mania. So today I'll be telling about the next video of StatPro, that is, let me first of all open StatPro, and there I will do the design as well as analysis of a multi-story building. So first of all, let me go to the new project space. The length will be meters and kilonewton. Okay, next, overwrite it. Yeah, I'll overwrite it. That's not a problem. Add beam, finish it. Okay, just wait for a moment. Yeah, the file has been opened now. Now let me close this grid section, and if you need any time, then you can just open it by clicking on this. Sorry, clicking on this one. Yeah, this is the grid lines. So the first thing you have to do is, first of all, you have to go to the geometry section, and in the geometry section you have to open run structure wizard. In the structure wizard, now you will have to select any kind of model like truss model, frame model, surface plate models, solid models, composite model. I will show you. These are the trusses, these are the frames, type of frames, then these are the plate, sorry, these are the plate models, these are the various type of plates, these are the solid models, then composite models, bunker or silos. Okay, then import CAD models. You can even import the DXF file from the AutoCAD, that I will show you. Then macro models, this are. Okay, so now I will do one thing. Now I will go to the frame section, and I will select as bay frame. In the bay frame, now I will give the length. See, this is a bay frame. Here I will provide the length. Suppose this is the length, then this is the width and the height. As you all know, first of all, let me go with the length, such as the length is 12 meter. Okay, number of bays along the length is 4, means 4 divisions will be there. So 12 divided by 4, it means each bay will be of 3 meter length. Let me do one thing. Let me go with 60 meter length. 60 meter. Now provide 4 bays. Okay, not an issue. Or do one thing. Let me provide here 5 bays. Now each bay will be of 12 meter, as 60 divided by 5. Now height is of 15 meter. 15 meter and number of bays along height means 5. It means what? Each bay will be of 15 divided by 5, 3 meter. So height will be 3 meter. Yeah, definitely. And remember one thing, that always we need to keep the height of the building as 3 meter. So it's that thing you have to remember. Let me do one thing. Let me do the design and analysis of G+3 building. That is how much? Ground plus 3. So ground floor is 3 meter, then another 3, another that is ground floor will be 3 meter, then above the ground floor there will be another 3 floors. So total how much? Total there will be 4 floors, and the number of bays along height will be 4, and if we need to keep the height of each as 3 meter, then 4 into 3, that will be 12 meter, and width keep as 50 meter of 525 applied. See, this is the one type of building which I have created. As you can see here, the height, as this is the ground floor. See, ground floor, first floor, second floor, third floor. So this one is G+3 building. Okay, So this is the building which I have created here. Even you can go to the edit section and even you can change it, okay, or you can do one thing, you can simply double click on this figure, then you can change it. Suppose I need to change the height as 10 meter and number of bays will be around 3. Suppose keep it as 12 and 3, and along the width suppose keep it as 15 and 3. Apply it. Yeah, so this is the building. Now what you have to do is, now either you have to simply go to this cross, or you can simply do it by this one, transfer the model. You have to click on this, so simply you click on this one. Yes, and see, remember that now they are asking for the reference point. What will be the reference point where I will paste this frame? So reference point will be 000. Okay, simply you need to click on OK. See, this is the diagram which I have created by the help of structure wizard. I hope it's clear to all of you. So this is the G+3 building which I have created by the help of structure wizard. Simply go to geometry, run structure wizard, and there you have to create this full building. Now what you have to do is, now suppose you have to do one thing. Suppose like you have to create in this building, suppose you have to see from a different view, like this is the view from plus z, then this is view from minus z, then this will be the side elevation, minus x plus x. This is top view, and this is bottom view, and this is the 3D view. Okay, these are the various type of views. So this is the building which we have created. Now let me go to the general part. In the general part, because I have created the figure in the geometry part, now let me simply go to the general part. In the general part I will provide now I will go to the property section. In the property section I will define rectangular. Now I will define the columns and beams, their dimensions. Let me provide the beams as 0.45 by 0.45. This is not for beams, this is for columns. Add it, concrete, add. Now let me provide for the beams as 0.4 by 0.4 for the beams. Add it again. Okay, done. Close it. Now you have to assign those beams and columns their properties to all these beams and frames. So what you have to do is, first of all you have to select on the property, that is reference one property, and after that you have to now go to select beams parallel to, because now I will be applying this property on the columns, so columns are in the y-axis, so simply types beams parallel to y-axis, assign to the selected beams, simply assign it. Yes, so these are the this reference one property is now applied to the selected all the columns. You can see in the 3D view, see all columns are being applied with this property. Cancel it. Just wait. Now you have to apply the property for the beams. Now select this portion, and again you have to now go to the select beams parallel to x-axis. These are the beams which are parallel to x-axis. Now again go to the same thing and select beam parallel to z-axis. So all beams are now selected. Now simply assign to the selected beams, assign it. Yeah, now all the beams and columns, their properties are being assigned. Now you can go to the 3D view. See, this is the full frame which I have now created. Now after that you have to apply for the plates, that is slabs. So simply you have to go to the front view, and after going to the front view, close it. This portion you close it because now I have already assigned the properties. These are the nodes, you can close it. Simply you maximize this part. Now the main thing now you need to do is in the symbols and labels, simply go there and click on node points so that the node points are clearly seen. Apply it on OK. So now the nodes points are clearly shown. You can go even to the 3D view. I'll go to the view from plus Z. After that, now you have to apply for the plates, and for that you have to do one thing is you have to go to the cut section command. That is, as you can see here, this is the cut section command. You have to click on this section. Now select to view. Okay, now you will cut this section. Okay, you have cut this section. Now after that you apply from top view. This is the top view. Now what I will do is, now I will assign the plates over this section. So now go to the plate cursor. This is the plate cursor here. After going to the plate cursor, yeah, this is the plate cursor. This plate cursor is used for actually selecting the plate. Now I have to assign, add the 4 noded plate. So go to this point, 1 2 3 4. Now in the same manner you have to add plates for the full building, and I am doing this part in the roof of the ground floor. Yeah, now everything is done. Now I will do one thing. Now I will click on view from Z axis. Okay, or let me do one thing. Let me click on top view only. In the top view I can show you the 3D diagram. Yeah, as you can see in the 3D diagram that in the floor, that is in the roof of the ground floor, this is the ground floor, and in the roof of the ground floor you can see I have provided plates. These plates now I will copy it in all the roofs of the first floor, second floor, as well as third floor. So what I have need to do is just wait. Yeah, So I now need to simply click on geometry part. After that, what I'll do is I will select. Now I'll go to this plate cursor and I'll select. Simply you have to type on control and select it. Okay, I have selected. Now what you have to do is you have to click on translational repeat. Translational repeat is the type of command which is used for copying. So I have selected all the plates, and I am by the help of this plate cursor, and I will now click on this translational repeat, and this one is the circular repeat. For translational repeat I will click in. Now in which direction I will copy these plates? I will copy all these plates in the Y direction, because I will copy all these plates in all the roof. So let me select Y direction, and number of steps is 1. What is the distance height of each roof? 3 meter. Okay, 3 meter. In how many steps you will copy it? See, this is G+3. So in the ground floor I have already copied. Now you have to copy on another 3 floor. So in this 3 floors it will get copied. So press OK. I hope the translational repeat is clear to all of you. Now we can check this on the figure in the 3D view. Let me close it. Let me display the whole structure. See, the cut section command will get cancelled after clicking the display whole structure. Yeah, display whole structure I have clicked it. Now let me check the whole 3D structure. As you can see here, now the whole structure, in the whole structure the plates are got copied. Now again you have to go to the again you have to now go to the geometry part, general part, and there you have to provide the thickness. I have provided the define, and I have provided this 2 thickness for the beams and columns. Now I'll click on thickness. Now I have to provide for the plate thickness. Let me provide the plate thickness as, what is the thickness of the slab? Let me provide as 120 mm. So I have provided here 120, and it will automatically get selected in all the nodes. Simply add it, close it. Now you have to simply click on this one. I have assigned this to, but third reference I have not assigned, so simply click on assign to view. I hope it's assigned. See, so now I hope it's clear to all of you. In So now let me do one thing. After the construction of the building is the frame, see, I hope it's clear to all of you that in what manner you need to create the beams, columns, that is the full frame, along with the frame, the plates, in what manner you have to apply for the plates. And after that you have to give the properties of the thickness of the beams, columns and plate. I hope it's clear to all of you. After that you have to apply for the support. Now go to plus Z, view from plus Z, create fixed support, add it. Simply click on fixed support, use cursor to assign, click on assign. Sorry, now what I have to do is, now I have to click on node cursor and I have to select in nodes. These are the nodes which I have selected. But in the 3D figure, if I will show from 3D, I hope it's clear to all of you, all nodes are being selected in the bottom portion. So you need to go simply to the plus Z and click on this node cursor, and in this way you have to select all the nodes. Now assign to the selected nodes, assign it yes. Sorry, just do it Control Z, or you can do one thing, or you can just simply delete it. Yeah, delete the support, then again create it. If some error occurs, you have to uh, rectify in this manner. Simply go to plus Z, click on this one, click on this, okay, assign to the selected nodes, assign it yes. Okay, now I hope it's clear to all of you. See, as you can see here, it has been assigned to all the nodes in the bottom section. So now the support is being created. Now you have to apply for the load. Now go to the load section. Now the main difficulty comes in this section, in the load section, because here you have to apply for the various kind of loads, such as concentrated load, such as a dead load, live load, then dynamic load also you have to, that is dynamic load means seismic load you have to apply. Then you have to apply for the wind load, various type of loads you have to apply. But as this is G+3 building, so I will apply here only the live load and dead load. But in my next figure I will be applying for the different other type of loads. So in my next exercise I will teach about that, but here I will be applying for the load combination as well. So you have to simply, you have to go to the load case detail, add it. Here you have to go for dead load, and you have to here type as a dead load, add it. Now go to the live load, simply type as live load, add it. Okay, done. Dead load and live load. Then after that you have to go for the roof load, roof load, again add it. These are the three loads I have applied. Now go to this dead load and click on add. In the dead load, the self-weight load which is already showing, that is in the direction y and -1, simply add it. Added, dead load added. Now go to the member load. In the member load you have to now add for the load, that is, let me apply the dead load of 3 kilonewton per meter in the minus y axis, add it. Now again go to the live load. Actually the dead load which I have applied here, this one is actually the dead load. This is the self weight I have applied here, because it is created by default -1 factor, but this portion I have to calculate it, not I have to simply type it. Just do one thing, just go to again the edit section, then click on calculator. Now as you all of you know that dead load is actually because of what? Because of the full structure. So do one thing, the dead load is actually applied over all the beams. Okay, so you can do one thing like uh, you can do like I'll show you. Go to the calculator here. सो मैं क्या करूंगा इसमें 20 24। देखिए आप लोगों को पता होगा कि व्हाट इज द यूनिट वेट ऑफ कंक्रीट एंड व्हाट इज द यूनिट वेट ऑफ आरसीसी। सो यूनिट वेट ऑफ जो कंक्रीट है वो हमारी 24 है और आरसीसी की जो होती है 25 होती है। सो 24, क्योंकि देखिए आप लोगों को पता होगा, देखिए मैं बहुत डिटेल्स से बता देता हूँ आप लोगों को जो डेड लोड एंड लाइव लोड और जो भी है, ठीक है, इनके बारे में। जो डेड लोड है हमारी, सबसे पहला क्या होता है, सबसे पहले हमारी रूफ आता है। जो रूफ है एकदम टॉप लेवल, देखिए कोई भी एक फ्लोर में आप लोगों को डिटेल्स में समझा देता हूँ, बाकी आप लोगों को क्लियर हो ही जाएंगे, सब फ्लोर में सेम ही है। सबसे जो टॉप फ्लोर है, टॉप फ्लोर में क्या होगी, बहुत चीजें एक रूफ के ऊपर आ जाता है। जैसे मैं आप लोगों को बता दूंगा, जैसे क्या होता है, एक हो गया हम लोगों की जो स्लैब है, जो कि रूफ होता है या स्लैब होते हैं एकदम, जो कि मतलब एक बिल्डिंग के ऊपर ऊपर बिछाया जाता है, उसका जो वैल्यू होगा ना, उसका थिकनेस। सो वी हैव टू टेक दैट थिकनेस एज 24। ओके, सो 24 हो गया उसका थिकनेस। द थिकनेस ऑफ दैट रूफ विल बी 20, और दैट स्लैब विल बी, its density unit weight will be 24. 24 will be the unit weight, so we have to multiply the unit weight. Along with the unit weight, we have to multiply its thickness. What is the thickness of the slab? The thickness of the slab is, we have taken as 125 mm. So what will be its weight? Its weight will be 3 kilonewton. So I have written here 3 kilonewton. So actually what is this one? Actually this one is the weight of the slab, but remember that here I have created as uniformly distributed load, but it is not created in the form of uniformly distributed load. Simply I have to can say delete this part, and I have to go to the dead load, and I have to again add, click on add, and I have to go to the floor load, and I have to click on 3 kilonewton per meter square. I hope it's clear, it's per meter square, because I have multiplied only two things, that is, one is the density unit weight of the concrete, and second one is the thickness of the roof. Let me cross check once again what is the thickness of the roof which I have considered. Go to the general part, go to the property part, and plate thickness as, okay, I have taken as 120. So let me do one thing, let me remain as 120 here, and in the calculation part again I will go back, load case detail, dead load here I has calculated, then again go to dead load, add once more, floor load calculator. Now 24 into 2.88, I have to keep it as 2.88 minus of 2.88. This one is the thickness, this one is actually the floor or roof load. And what will be the height? You have to check the height. See, you have to go to the node cursor and you have to click on this one. What is the height here? Y-axis is 3 and 3 to 12. So you have to keep the minimum range as 3 and maximum range as 12. So I have to add it. This one I have added. Now again we have to add for another load, that is, you have to again go to the dead load, add. Now you have to add for the floor finish. That is what will how I will calculate the floor finish calculator. See, remember that the for the floor finish I will take the density of the mortar as, Here I will be applying for the mortar but not concrete for the finishing of the floor. So I will take the density or the unit weight of the mortar as 20 into, let me take the floor finish thickness as 50 mm. Okay, so 50 mm, that is 50 divided by 1000, that is 0.05. So 1 is the load, so I will provide here -1, the same range, that is 3 to 12. Add it. So these are the three dead loads which I have provided here. Okay, but you have to remember one thing, that along with this, the dead load over the full structures also comes for the dead load of the walls, that is which I will be provided. There are two type of walls which are present in any kind of building, that is partition wall as well as the load bearing walls. Okay, so I hope all of you know about partition walls and load bearing walls. So let me do one thing, let me okay let me do one thing, go to the dead load and click on add, and in the add section, now I will be applying the load for dead partition wall and the load bearing walls. So let me first of all add for load bearing wall. Now go to the member load, after that uniform force. So again go to calculator, in the calculator, what is the unit weight of mortar? The unit weight of mortar, take it as 20 kilonewton. Okay, 20 kilonewton per meter cube. Okay, now you have to multiply this one with the volume. What is the height of the walls? Height of the wall is 3 meter, not 0.3. You have to multiply this one as sorry 20 into 3 meter is the height of the wall. Okay, so multiply by that, then after that it's what is the thickness? So for the load bearing wall, take the thickness as 0.3 or 0.23. Okay, so this one is actually the load. So remember that for finding out the dead load of the load bearing walls, we have to multiply the unit weight of the mortar, which is 20 kilonewton per meter cube, multiply by the height of the wall into the thickness of the wall, which is equal to 13.8. So now minus 13.8. Okay, so simply click on add. This one is added here. Now you have to click on, go to the calculator again. Now you have to calculate for the partition wall, that is 20 multiply by thickness of the wall 3 meter, multiply by height of the wall 3 meter, multiply by the thickness of the partition wall, which is equal to 0.15 or 150 mm. So it is around 9. So take the thickness as 0.15. I have taken the thickness as 0.15. You can take different thickness, so because based on this different thickness the load will be different. So 9 kilonewton. So I will type here 9 kilonewton, add. See, this one is for, remember that this one is for the self head, this one is for the floor or roof load, this one is the floor finish load, this one is for the load bearing wall, this is for the partition wall. Now I will again calculate for the live load. See, remember, you have to remember one thing, that all these dead load which I have created here, these are based on IS 875 part 1 IS code book. IS 875 part 1, that is for dead load. So I have to calculate all this as per the IS 875 part 1. Now I have to assign for the live load. Now click on live load, click here, go to the floor load, and remember that as per IS 875 part 2, that is for live load, I have to provide the floor load as 2 kilonewton per meter square. Range is 3 to maximum height, that is 12. Okay, done. So dead load I have provided, live load I have provided, roof load, there is the no requirement of any roof load, so simply delete this, because I have already included all these dead load and live load in this portions only. Roof load also I have uh, calculated in this dead load as well as live load. See, this one is already, the roof load is already assigned here. Self weight of the floor already assigned, self weight of the floor finish already assigned. Now we have to apply for the self weight. Self weight, simply click on assign to view and assign it. Assigned. Now go to, you have to now assigned in a very particular manner for the load, that is for the uniformly distributed load, or the load of the main walls or load bearing walls. After that we have to apply the load for the partition walls. So do one thing, as all of you know that load bearing walls are present only and in the boundary sections, and you have to also remember one thing, that in the top floor, above the top floor, there is neither partition walls nor there are load bearing walls. So in that top floor you don't have to apply, simply you have to apply in the ground floor, first floor, second floor, not in the third floor. So let me do one thing, let me view this section, that is I have viewed in the positive z-axis. Now simply click on dead load. Now where I have to apply it, now I have to apply on beam cursor. Now select the beams. Let me check in the 3D figure what are the beams which are selected. See, as you can see here, all beams are selected. So again go to this section. First of all, do one thing, let me cut the section. Yeah, yeah. Now go to the top view. Now I have to select the beams. Yeah, I hope it's clear to all of you. So assign it. Now after that, now go to the So you can apply in this manner, or else you can apply in a very simple manner. I will show you now. Or let me do one thing, apply in this manner, such as this is the load which I need to apply. Okay, so do one thing, go to the load, that is minus of 13.8 kilonewton per meter is the load. I need to go to this load, then I have to, because see, this is the load which I need to apply only on the load bearing walls. So I will go to the view from top axis, and after that, after view from the top axis, I will select all the beams which are in the periphery. So select this beam, so I will select all the beams which are in the periphery. Now I will view from the, see, 3D view. See, all the beams which are only at the boundary, all those beams are being selected. Now I have to click on assign to the selected beam and assign. See, all the beams I have selected, but remember that I have clicked on the load, that is dead load, that is the load for all the beams. But remember one thing, that this is the load of the load bearing walls, but remember that load bearing walls are not present at the top level. So I have to unselect only for the top level. So again, do one thing, click on control and unselect only for the top level. Or you can do one thing, we can simply go to the geometry, because in the load portion the loads are also showing. So simply go to the geometry portion, there you can go to top view, and there you can again select now view. Yeah, now again unselect all in the top level, only at the top level. Let me do it in a proper manner. Let me do one thing, let me go to the front view, then do one thing, go to the cut section, select to view. Okay, select the 3 sections from here to here. Okay, now go it to the top view. After going to the top view, now select all the beams. Yeah, I hope it's clear to all of you that in what manner you have to select all this load bearing, that is all the beams over which load bearing walls will be present. After selecting this, go to the general section, go to the load and definition section, go to the load section, go to the dead load, and this is the load. Now assign to the selected beam and assign it. Yeah, I have assigned the load. After that, now I have to show the full structure. See, at the top it is not assigned. Now I have to apply the load over the partition walls. So again, go to the geometry section, there go to the top view, then select all the beams. Again, in the similar manner, I have to go to the cut section and select the 3 sections. Okay, I have selected the 3 sections. Now after selecting the 3 sections, now I will select all the walls. Now again I go to the top view. Now I will select all the beams which are internally present. Because these are partition walls. Yeah, these are the partition walls. Yeah, I hope it's clear to all of you. Only with the walls I have selected. And now go to the general. Now go to the load and definitions. Now go to the dead load. Assign to the selected beam. This is now I will be applying the load over the partition walls. See, this is how we have to apply for the load over the partition walls and the load over the load bearing walls in a very precise manner. After that, now go to the live load. I hope live load is already applied. Now again go to the load case detail and click on add. Now do one thing. Now go to the load combination and now go to the load combination and click on name as dead load plus live load. Okay, and click on factor as 1.5 and for this one also 1.5 and click on add. I hope it's clear to all of you. So now I have created a dead load, live load and combinations. Now go to so now I'll click on analyze, add. Okay, now I'll click on analyze. So let me do the analyze. Okay, so I hope it's clear to all of you. Now analysis is over. Now I can go to the post processing mode and let me check. See, this is the figure. In this figure, post processing mode is over. Now I can check for the deflection diagram. Here I can check for the deflection diagram. I can little bit decrease the deflection diagram. See, the deflection is showing here. Even I can check for the reaction. These are the various reactions and animation of the deflection diagram. See, this is the animation of the deflection diagram. After that, these are the various reports. You can click on the reports. These are the reports of the. You can even print out the reports. So I hope it's clear to all of you. So this is the analysis part. After the analysis is over, next you have to go to the you have to go to the design part, and in the design part click on concrete IS456. Okay, select the parameters, unselect all. Then after that, compressive strength of concrete, then yield strength of main, yield strength of shear, maximum size of secondary, maximum size of main reinforcement. Okay, done. After that, define the parameters such as M20, then 20,000, add it. Then main reinforcement FE 415,000, add it. Let me close it, check whether then secondary 415,000. After that, go to maximum size of main reinforcement 16 mm, add it. Maximum size of secondary reinforcement 8 mm, add it. Let me check here. Okay, done. Now assign to view, click on assign to view. Now main reinforcements assign to view, secondary reinforcement assigned to view. After that, minimum reinforcement assigned to view, main reinforcement, secondary reinforcement assigned to view. After that, go to commands and design of beam, edit, design of column, edit, design of slab, edit, and take off, edit, and close it. After that, you have to design of beams, you have to assign to the selected beam. Now go to the command section, sorry, select section, and beams parallel to x-axis, as well as select the beams parallel to z-axis. Now assign to the selected beams for beams. Now go to the design of columns. Now go to select the beams parallel to y-axis, assign to the selected beam, assign. Now design of elements, simply click on assign to view, take off. Everything is done. Now close it. Now go to analyze and print again, click on add. Now close it. After that, do the run analysis. Yeah, now go to the post processing mode, done. So this is the analysis which is over. Now you can do one thing. Now you can simply go to the stat output here. You can click on this one. In the stat output, you can check for everything, every results you can check it here. What are the top reinforcements, what are the bottom reinforcement, what are the stirrups which are provided, everything is present here. Simply you can print out, take the printout of these results. Everything is present here. Even there is present here how much amount of reinforcement 57702 unit weight is required, amount of concrete 108 meter cube or cubic. So I hope it's clear to all of you. So everything is clear. Now you can even go to the result section, concrete design. In the concrete design, this is the concrete design portion, and okay, so this is the stat output where you need to check it, and even this is the stat editor. This is the stat output where I have showed you the results. Okay, so even you can go to this report part and you can go to that what are the things which you require, like beams, plates section. You can select everything and click on OK. It will show you all the reports, like next page, next post. See, all the reports are shown here. Now even you can go to another thing, like in the design part only. There you see, this is the result for dead load, then live load results, then dead load plus live load. This is for combinations, results will be shown here. Or you can also do one thing, you can simply click on any member, or you can double click it and you can check for the concrete design. So this is the diagram which is shown here. See, remember that after the designing part is over, after that you have to do the designing of this footing part. which I'll show you in my other videos. Okay, this is how we need to do the analysis and the design of the multi-story building. After that, now I'll show you the design and analysis of the different buildings along with the wind load combinations as well as seismic load combinations, okay, in my further videos. I hope it's clear to all of you. So if there is any doubt, just comment me on my comment section. And if you like the video, then please press the like button, and if you have not subscribed my channel, then subscribe yet and share as much as possible. And thanks for watching my video.